is Mrs. Taylor, and I'm going to walk you through how to solve an equation, quadratic equation, by completing a square. So the first step in this process is to divide by the a value. Now for this particular example, that step doesn't have to happen because a equals 1. A is the number here in front of the squared term. And if a is 1, I've divided everything by 1, nothing changes. So I can skip that step and move to the next step, which is to move c to the opposite side of the equal sign. So in this equation, negative 97 is my c value, so I'm going to move it to the opposite side of the equal sign, and that means that once I do that, it's the opposite sign, so it'll be a positive 97. Now, the next step is we're going to add a number to both sides of the equation, but it's a very specific number. It is the number that is going to complete the square. It's the number that will allow the rest of the process to happen correctly. And so the way you find that number is with the formula. So you're going to add b over 2 all squared to both sides of the equal sign. And the reason it's that particular number is, like I said, it's the number that completes the square that allows the rest of the process to happen. So b divided by 2 all squared. Our b value is negative 16. Negative 16 divided by 2 is negative 8. Negative 8 squared is 64. So then I would take that number and I would add that to both sides of my equation. Now, if we did that step correctly, the next step should be quite easy. So, we're going to factor the trinomial, and I'm going to write it as a binomial squared, and it's very specific binomial. If I did step 3 correctly, it should be x plus b over 2 squared. Okay, so let's test and see if we did it correctly. So I'm going to factor this trinomial here. What are two numbers that multiply equal 64, but add to equal negative 16? And that would be negative 8 and negative 8. So if I factor the trinomial, it will look like that. I'm going to go ahead and add 97 plus 64. What would that be? That would be 150 plus 11, 161. I think that's right. I should probably check that. 97 plus 64, yep, 161. Okay, so this thing in parentheses here, right, as binomial squared, what I should notice is that both binomials, when I factor, are identical. The reason that works is because we use the formula to find this number here. Now it's a binomial squared, and this number here, if I did everything correctly, should always be the b value divided by 2. b is negative 16, divide that by 2, you get negative 8. So I did it correctly. Now the next step is what we would do to solve this equation. We would take the square root of both sides of the equal sign. So if I take the square root of both sides, it would look like that. The square root of something squared, those are inverse operations, so they cancel each other. And it's 161 a perfect square. No, it is not. So I would then try to factor 161 if I could. There are no factors of 161 that are perfect squares. So I would leave it in simplified form as a radical, square root of 161. And remember, when you take the square root, it's always a positive and a negative. And so then after I do that, I break my equation apart into the two cases where it equals positive square root of 161 and negative square root of 161. And I would finish by adding 8 to both sides. Now, 8 and the square root of 161 are not like terms. So a simplified answer would just be the square root of 161 plus 8, add 8 here, and you would get k also equals the negative square root of 161 plus 8. So those would be my solutions. Now, one thing you always need to do is check your work. Now, you may think, oh, that takes too much time, it's not worth it. It is, especially on a poster quiz, because a lot of times if there's an error, it's really easy to spot if you just go back and look for it. So, I'm going to plug this first solution, square root of 161 plus 8, into my original equation. Always checking your original, because if you made a mistake somewhere along here and you plug this into one of those equations, you might not realize you made a mistake. So, k squared would be the square root 161 plus 8 squared minus 16 times the square root of 161 plus 8 minus 97. And if I solve correctly, I have to do 0. Uh-oh. So this is a perfect example of where the calculator is a little flawed, because that doesn't look like 0, but if you interpret it as it's meant to, it's actually practically 0. What this is scientific notation. So it means that it's the same thing as having 1 times 10 to the negative 11. So if you think about that, this is an aside. 1 times 10 to the negative 11 would be moving my decimal to the left 11 places. So my 1, and I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I fill in all of these spaces with the zeros, that is practically 0. And so we are to interpret that as 0 when we're using the calculator. Again, it's not a perfect system, it's flawed, it's calculator makes estimates, but that's practically 0, so I'm accepting that as the solution. If I hit second enter, I can get the calculator to copy and paste what I last entered, and then I can just change the square root to a negative. And the way I can just insert a negative is just second insert. And then once I type over what's there, it will just insert what I asked it to. And again, I get something really, really small, practically 0. So I know I did this correctly. And so that's how you would solve this equation by completing this